All right, the last part of our example was part 4. Find and interpret the residual for the can that was tapped for 4 seconds and had 260 milliliters of soda remaining. We had a couple 260s, but the residual will be the same for any of these guys. So a residual is defined as the observed y minus the predicted y. So y minus y hat. Our observed y was 260 milliliters, so we need to go and figure out what our predicted y was. So the predicted amount of soda for 4 seconds of tapping time, because that's our x value here, 4. So I'm going to go ahead, plug 4 in for x, and then I'm just going to simplify this in my calculator. 248.6 plus 2.63 times 4. I get a predicted y of 259.12 milliliters. So this is my y hat for this particular problem. My y is 260, my y hat is 259.12. You can see our predicted value is very close to what we observed. So let's go ahead and plug those in. 260 minus 259.12, and you can see that we get a residual of 0.88. And the way that we would interpret that would be our predicted value, and we always like context, so our predicted amount of soda left is 0.88 milliliters lower than what we observed. So, of course, our predicted value will always be a little bit off of what we observe in real life. Our residual tells us how much. In this case, our prediction was 0.88 milliliters lower than what we observed. So that is how we can find and interpret residuals. That is the end of 3.2. So you guys can go ahead and work on your 3.2a assignment in your textbook.